Hello and welcome to my channel. So today we are going to proceed by looking at questions that are a bit complex. So we are going to be looking at the 5 questions today, and we're going to be starting with the first question, which says that 2a raised to power 2 times all into bracket 5a raised to power minus 2, and that we should evaluate. So how do we evaluate this? So number one, 2a raised to power 2 times 5a raised to power minus 2. So how do we go about this? Well, this is also quite easy. So what you are just going to do is anywhere you see a negative power, try as much as possible to take it to its reciprocal in order for the negative to what? Become positive. That is just the first thing you are going to do. So from here, I will say this is 2a raised to power 2 times, now listen please, as you can see, that this raised to power minus 2 covers everything in this bracket. Unlike the first one that we have 2a raised to power 2, we can see that 2 is affecting only a. Unlike this one, minus 2 or power minus 2 affects both 5 and a. So in this case, I will say times 1 over 5a all into bracket raised to power 2. So what have I done here? I have succeeded in making this negative to be what? Positive by making it to be 1 over. And let's not forget that anywhere you see negative, please let this thing come to your mind. That when you see a negative power, what you just come to your mind is 1 over, and the power becomes a positive power. I've explained all this in my second video relating to laws of indices. So let's proceed. Then from here I can say this is equal to 2a raised to power 2 times 1, that is 2a raised to power 2 divided by 5a all raised to power 2. So at this stage I can say this is 2a raised to power 2 divided by, let's not forget that the power you see here outside this bracket means that it will distribute itself to the elements you can find in this bracket. And from here, we can only find, we have two items or elements here, as we can call it, and that is what? 5 and a. So it means that it's going to be 5, it's going to be 5 raised to power 2 times a raised to power 2. So which is equal to 2a raised to power 2 divided by, I know that 5 square means 5 times 5 times a raised to power 2. So automatically I can say this is 2a raised to power 2 divided by 25a raised to power 2. And automatically I can say a square cancels a square. And what do we have? We have 2 over 25. And that is our answer. So let's move on to the next one. The next one, sorry, I have to clean this. The next one, which is number 2, we have 3a raised to power 3 all into brackets raised to power minus 2 times 6a raised to power 2. Now let's look at this. 3a raised to power 3 all into brackets raised to power minus 2. What does it mean? It means that the power outside affects everything here. But the first thing we are going to do is make sure we turn this negative power to a positive power. And the way we have to do that is when you see this negative, let 1 divided by come into your mind, and the power that was negative before will what? Change itself to positive. So from here, I can say this is the same thing as saying 1 over 3a raised to power 3 all into brackets positive 2. Can you see now? So I can say this one has been transformed, though it's just a kind of conventional way of me saying it. The proof and everything has been done in the laws of indices. So I'm just saying this just for us to know and to remember so that we won't forget. So times 6a raised to power 2. Then I can as well say this is simple as saying 1 times 6a raised to power 2. I'll say this is 6a raised to power 2 divided by, now these two will affect 3 and it will also affect a raised to power 3. So let's watch out. So it's going to be what? 3 raised to power 2 times a raised to power 3 times 2. Can you see? These two will affect 3 and these two will also affect a raised to power 3. So we have 6a raised to power 2 over 3 times 3 times a raised to power 6. Let's not forget that 3 squared is 3 times 3. So I can as well say this is 6a raised to power 2 divided by 9a raised to power 6. Now, as you can see numbers on one side, that is the numerator and the denominator, and we can also see letters on the other side, which is also at the numerator and the denominator. So I can as well just divide this one normally to its lowest term. The common number that can divide 6 and 9 is 3. So I'll say 3 going in 6, that is 2. 3 goes in 9, that is 3. And so we have 2 over 3. Using law of indices to trash this one out, don't forget that x raised to power a divided by x raised to power b in the second law of indices is what? X raised to power a minus b. So on this note, since the letters are the same, I can as well say this is simple as saying a raised to power 2 minus 6. Let's not forget because of the division sign, that is why we are seeing minus. So I can as well say the answer is 2 over 3 a raised to power minus 4. And since we have something like this, we can just round up by saying that we can say this is 2 over 3. 2 over 3a raised to power minus 4 can also be said, can also mean 2 over 3 times a raised to power minus 4. So I can as well say times, because this negative, we need to change it to positive, and I can say this is 1 over a raised to power 4. And my answer will be 2 over 3a raised to power 4. And that is our answer. So we are proceeding. So let's move on to number 3. Moving on to number 3. Number 3, it says, number 3, 2x raised to power 3 divided by 4x raised to power 2 or into brackets minus 3. So how do we go about this? The same way, the same style, the same pattern. So I can as well, this one can be, I can say this is 2x raised to power 3 divided by, this one can be likened to be 1 over 4x raised to power 2 all into bracket 3. Can as well do it this way, because this 2x raised to power 3, this is it, divided by, this is the division, and don't forget that this is minus 3. To change it to positive, I have to say 1 over, I have to write 1 over, then 4x raised to power 2 all into bracket 3. And you see, the negative has changed to positive. So I can as well from here say that this is my numerator and the whole of this is my denominator. So how do I transform? I can say this is numerator divided by denominator. Numerator divided by denominator. So which in turns will mean 2x raised to power 3 times 4x raised to power 2 over 1. However, from the beginning, if you want to, you can also start like this. Like I can as well say 2x raised to power 3 divided by, I already know that this one will end up to be 1 over 4x raised to power 2 all into bracket 3. I can also do like that and I'll still get my answer. And of which when I change it to multiplication, it goes up. Like I'll show you now. That is equals to I can as well say this is 2, just arrange the letters and numbers. I can say this is same thing as saying 2 times 4 times x raised to power 3. Oh, sorry. Let's do it this way. Let's say 2x raised to power 3 times this 3 will distribute itself in, so it's going to be 4 raised to power 3 times x raised to power 2 times 3 over 1. So we have 2x raised to power 3 times 4 raised to power 3 is 64. So we have 64 times x raised to power 6. I hope you all know that over 1 means that it is the number back. So then just multiply. I will say this is arrange numbers separately and letters separately. So this can be 2 times 64 times x raised to power 3 times x raised to power 6. So 2 times 64 is 128 times, using laws of indices, as you can see that this is x raised to power 3 times x raised to power 6. It shows that this, since the letters are the same, we can apply the law of indices, which says that x raised to power a times x raised to power b equals x raised to power a plus b. So it's going to be 3 plus 6. So we have 128 times x raised to power 9, and our answer is 128 x raised to power 9. So what I said initially was, I said the method I used here can also apply to this too. I can skip this method. I can skip this side by just saying 2x raised to power 3 divided by 1 over x raised to power 2 all into bracket 3, and I can continue. However, I can also do it like this and also get to this level and continue. So whichever method you use, there's no problem. You can use this and you can just jump right by just saying 2x raised to power 3 divided by 4 over this and continue solving. There's no problem with that. So that is our answer for number 3. Then we proceed by moving on to number 4. Number 4. Now let's listen attentively to number 4 and number 5. Number 4, 50x raised to power 3 over 2 equals 8x raised to power minus 1 over 2. Now, there is an equality here. So automatically, from this question, we have been asked to find the value of x. So how do we get the value of x? Before we proceed, I want you guys to understand something, that while solving anything that deals with algebra, anything related to algebra, try as much as possible to make your letters be on your left hand side and the numbers to be on your right hand side. So our aim is to find the value of x, and apart from that, our aim is also to make sure that the value of x stays on my left hand side. So as you can see this question rather, you can see that the question is kind of scattered. 50x, 8x, x here, x there, number here, number here. So why don't we arrange by putting the value of x rather on our left hand side and numbers on our right hand side. So how do we go about it? Right. So let's proceed. So our aim now is to make sure we convert letters from here to our left hand side. So how do we do that? So let's get started. So I would say this is 50x raised to power 3 over 2 equals 8 dot here means times, or I can say 8 times 1 over x raised to power 1 over 2. Let's not forget that this raised to power minus half affects only x. It doesn't have anything to do with 8. And likewise, these two, x raised to power 3 over 2, affects only x. It doesn't have anything to do with 50. So let's note that. I can as well say that this is I can as well say as in multiply both sides rather by x raised to power 1 over 2, because my aim is to make sure the number stays here, and my aim is to make sure that the letter goes to my left hand side. So what do? I will multiply both sides by x raised to power 1 over 2. So let's do it. So we have x raised to power 1 over 2 times 50 times x raised to power 3 over 2. Let's not forget that 50 x raised to power 3 over 2 means 50 times x raised to power 3 over 2 equals 8 times 1 over x raised to power 1 over 2 times x raised to power 1 over 2. Why am I multiplying both sides by x raised to power 1 over 2? Because I need to get rid of this denominator. Why am I getting rid of this denominator? So that at the end of the day, I can find what I am multiplying both sides with on the other side, in order for the x to be together. So I can, when I cancel this, I have x raised to power 1 over 2 by arranging x raised to power 3 over 2 times 50 equals 8. Aha. So now we have 8. Now our next issue now is we don't want 50 to be here. We want 50 to fall into our right hand side so that it will be well arranged. So how do we go about this? There's no big deal here than for me to just multiply both sides by 1 over 50. By 1 over 50. Let me just give you a quick note here that if you want to make any number to be equal to 1, if you want to make any number to be equal to, the only way we can let this 50 to go away from here is by making it to be equal to 1. And how do we make it to be equal to 1? By multiplying both sides by its reciprocal. For example, if I say this is 2 over 3, and I want to multiply this by its reciprocal, I will say times 3 over 2. Because I know that at the end of the day, when I divide, I'll get 1 as my answer. So in order for us to get rid of this 50, we are going to make sure that this becomes 1. How do we make it to be 1? We make it to be 1 by multiplying both sides by its reciprocal, meaning that this is automatically saying 50 over 1, though we cannot see the over 1, but it is 50 over 1 because I know 50 divided by 1 it means 50. So 50 divided by 1 times its reciprocal, 1 over 50. So if I should multiply both sides by 1 over 50, automatically I've succeeded in getting rid of this 50 here by making to be 1. So how do we make it? So it's going to be x raised to power 1 over 2 times x raised to power 3 over 2 times 50 times 1 over 50 equals to 8 times 1 over 50. That is, I've multiplied both sides by 1 over 50. Let's do a quick recap. Let's look at what we did here. If you look at what we did in our previous step rather, we multiplied both sides by x raised to power 1 over 2. Why did we do that? Let's not forget that I wanted to get rid of this side. I wanted to make sure this 1 over x raised to power 1 over 2 becomes 1. And how do I get rid of it? By multiplying. I know that when I multiply this side by x raised to power 1 over 2 and divide, it will definitely give me 1, because the reciprocal of this 1 over x raised to power 1 over 2 is x raised to power 1 over 2. Reciprocal means the opposite, just like the opposite of something. So if I say, what is the reciprocal of 2 over 1? It is 1 over 2. What is the reciprocal of 1 over 2? 2 over 1. When you multiply a number with its reciprocal, it will definitely give you 1. Let's not forget that. So from here, what am I going to do? So I will say this is simple as saying x raised to power 1 over 2 times x raised to power 3 over 2 times 1. So this automatically cancels. So we have times 1 equals to 8 times 1 over 50. So we have x raised to power 1 over 2 times x raised to power 3 over 2 equals 8 over 50. Now, we have succeeded in what? In separating numbers from letters. We have succeeded in putting letters on our left hand side, and we have also succeeded in putting numbers on our right hand side. So the next thing we are going to do is just apply the law of indices and then round up with our answer. So from here now, I can see that x raised to power 1 over 2 times x raised to power 3 over 2 automatically means, in our law of indices, means x raised to power 1 over 2 plus 3 over 2 equals 8 over 50. So from here, I know that we have, if since the, please take note of something, when you are finding the LCM and you notice that the denominator, the numbers are the same, there is no need in looking for the LCM. Automatically the denominator here is going to be what? 2. Then I will just say 1 plus 3, that is 4, equals 8 over 50. And I can as well, and it can also be divided, so it's going to be x raised to power 2 equals 8 over 50. Now, to find the value of x, what am I going to do? I can say x equals the square root of 8 over 50 to make, you see, or I can as well multiply both sides by half. When I multiply both sides by half, that is, you can either do it this way, but how we originate to this point is I multiply both sides by half. If I multiply both sides by half, automatically 2 cancels 2. Why am I multiplying both sides by half? Because I want to make it to be 1. I want to make x stand alone. And the only way I can make x stand alone is by making it to be x raised to power 1. So it means that if this is 2, then the only way I can cancel this 2 to make it to be 1 is by multiplying both sides by its reciprocal. And its reciprocal is what? 1 over 2. Since this 2 means 2 over 1, so its reciprocal is going to be 1 over 2 equals to, and this side 2, on the other side 1 over 2. And automatically, when I cancel, x stands alone, and at the end of the day, this 2 here becomes my square root. But however, you can as well just, we have known that anytime we see x raised to power 2 and want to make x stand alone, the only way to do it is just by making sure that this square turns to square root on the other side. And I can as well say, it is not, I cannot find the square root of 8 and 50. So this is just like a trap. You understand? So what we just need to do is to divide both sides to its lowest term. Not really, but divide in such a way that you will see the number that can literally be formed as square root. So I can say 2 in 8, 4, 2 in 50, 25. So I can say this is x equals square root of 4 over 25. And automatically I know that the square root of 4 is 2 and the square root of 25 is 5. So my answer becomes x equals 2 over 5. So the fifth question, we have 32x raised to power minus 3 equals 2x raised to power minus 7. 32x raised to power minus 3 equals 2x raised to power minus 7. The way we did this, the number 4, that's how we are going to do that of number 5. So from here, our aim is to make sure we take our letters to the left hand side and numbers to the right hand side. So I can as well say this is 32x raised to power minus 3 equals 2 times 1 over x raised to power 7. The negative, as let's not forget that. Then the next thing for us to do is to multiply both sides. Now I want to eradicate this side so that we can take it to this other left hand side. So from our right hand side, I can multiply both sides by x raised to power 7. The reciprocal of 1 over x raised to power 7 is x raised to power 7. That is like saying x raised to power 7 over 1. But I can as well say x raised to power 7. Why? So that when I cancel out, it will just be 2. And that x raised to power 7 will appear itself here because I've multiplied both sides by x raised to power 7. So let's look at how it is done. So it's going to be x raised to power 7 times 32 times x raised to power minus 3 equals 2 times 1 over x raised to power 7 times x raised to power 7. So from here, I can cancel out now. So at the end of the day, we have x raised to power 7 times x raised to power minus 3 times 32 equals to 2. However, we have another problem. Number shouldn't be here. Number should be on our right hand side. So what do? this is 32. So in order for me to eradicate the number here, or to cancel that, to take the number here away, I have to multiply both sides by its reciprocal. So if this is 32, the reciprocal of 32 will be 1 over 32. So it's going to be x raised to the power 7 times x raised to the power minus 3 times 32 times 1 over 32 equals 2 times 1 over 32. So in this case, I'll just say multiply both sides by 1 over 32. So we have x raised to the power 7 times x raised to the power minus 3. This cancels, so times 1 equals 2 over 32. So I can as well say this is x raised to the power 7 times x raised to the power minus 3 equals 2 over 32. So when I divide both to its lowest term, I can see this is 1 over 16. So I can as well say x raised to the power 7 times x raised to the power minus 3 equals 1 over 16. Now, using the law of indices here, using the law of indices, I know that x raised to the power a times x raised to the power b equals x raised to the power a plus b. So I can as well say this is x raised to the power 7 plus minus 3. There's minus 3 here before, over 1 over 16. So this is saying x raised to the power 7 minus 3 plus times minus is minus equals 1 over 16. And we have x raised to the power 4 equals 1 over 16. So here automatically, to make x stand alone, it means I have to multiply both sides by 1 over 4. Let's not forget that it's x we are asked to find, not x raised to the power 4. So if I multiply both sides by 1 over 4, 4 cancels this 4, then we have x equals 1 over 16 all into 1 over 4. And it's simple as saying the fourth root of 1 over 16. And what is the fourth root of 1 over 16? 1 over 2. Fourth root of 16 means that a number that when you multiply 4 times, it's going to give us 16. And the number that when you multiply 4 times that gives us 16 is 2. So our answer is 1 over 2. Thank you very much. And I hope you enjoyed the video. Hope to see you soon. Thank you.